All right, what is up, everybody? How are we doing today? We're back. Model Monday Live. Finally back. It's been a long time. I'm feeling pretty good about being back here with you guys, I gotta say. It's been too long. Let me see if I can get the audio levels looking good. Looks like my mic is a little too quiet and the music is a little too loud. Let's see if we can work some magic here. Turn these knobbies. Turn this knobby, turn that knobby. Check, check, check. Check, check, check. Let's see what we can do here. I think that probably sounds a little better. I hope it does. If it's out of line or anything's problematic, I'm going to trust you guys to let me know so that everything sounds good and looks good on this beautiful Model Monday Live episode. I always feel like I'm overdriving when I take the gain up that high. So let's see if maybe I can just turn it down just a smidge. Not too much. Okay. Thomas says, sounds good. Awesome. Great to see Jason O here. Jason O making copies, making sales too. That's what you need to be doing on a Monday. That's a great way to start the week. So congratulations. That is awesome. We got Jose in here today. We got Kirby. We got New Form Designs. Hasn't been here in a long time. What's up, New Forms? And Alfredo is here as well. Welcome, welcome. Let us know if you're here in the chat. Let us know if you're here for the first time. And I think we can probably jump right into it, right? We all know what we're here for. We're here for Model Monday Live, Monday, September 12th. Jed Hightower is in the chat. What's up? Bob McGoy is in the chat. What is up? Welcome, welcome. Great to see everybody in here. Let's get some speed modeling done today. We got 2 CAD speed modeling challenges today. We're gonna also take a look at some of the tourney solves. These are basically, I'll just go through and take a look at some of the challenges that have been in the tournament recently and try to get them to turn into the correct mass. And as I'm going through, I'll let you guys kind of like watch over my shoulder. I'll talk through my thought process and let you know how I would solve it if I was in the chair of the competitor. Of course, without all the pressure of knowing that the whole world is watching and that I'm going up against somebody else. It sounds to me like my microphone is overdriving, so you guys let me know if it sounds like my microphone is out of line, my audio is out of line at all. Like I said, I always feel like I'm finding that balance. Alrighty. Kirby says, how you feeling about Fusion after that last matchup? I was really impressed. You know, we had Kachu playing in the tournament this weekend, going up against H4i2, and Kachu was utilizing Fusion 360, and H4i2 was utilizing Inventor, and I was really impressed with Fusion. I was taken aback by the aesthetics of it. I thought it was aesthetically very pleasing, just to see it on the screen. You know, I don't know how that's going to affect actually working. Like all the models are always in perspective with almost like a cartoon shading. And I know that in SolidWorks, if your models are in perspective, things get really out of whack, particularly with your dimensions. So I don't know if Fusion has the same type of issues with everything in perspective, but it certainly looked really cool to see a 2D sketch go into a 3D model. And a lot of neat things too with the what's it called? The ability to convert edges. There was I don't understand exactly what Kachu was doing there. I definitely want to watch some more and see what he was doing, but the conversion of edges in that match was really cool. It's like a lot of flexibility with regards to existing edges. And, I know there's some capability like that in SolidWorks too, so maybe I just need to investigate a little bit deeper with some of the newer enhancements, but definitely was impressive to see it in action for sure. Yeah, thanks for the question, Kirby. What'd you think about it? If you guys watched the match this weekend, let me know what you guys thought about it as well. Jason O says it's a touch loud. We could adjust. The mic is a little bit loud. Let me see if I can. I think my gain is a little bit too high on this thing. At least it is in my ears. I think that's probably a little bit better. Subtle adjustments when you're working in audio. That's the trick. Subtle. I also just wanted to share with you guys, I sometimes see these messages. They come in a variety of formats on a variety of platforms, but this one was particularly interesting to me. And so this one came in and said, Speed modeling, which is what we're all here for today. Speed modeling is no more than a dog and pony show, a gaffer dazzler. A gaffer is a person in charge. Speed of modeling is irrelevant to solving problems, and that is what a good experienced engineer should be doing. You can teach best practice, good routines, and fast technique until the cows come home, but you cannot teach experience. And then he said, what you're doing is selling speed, which, sorry to say, is just snake oil. So there you go, snake oil salesman. That's me, TooTallToby, the snake oil salesman. I thought that, it's always interesting to see what people are willing to spend time doing. Spend time creating a comment that says, there's no point in getting fast at your professional trade because, every customer I've ever worked with just says, just take as long as you want. It doesn't matter. There's no deadline. You just take as long as you need. And if you're faster or slower, it really doesn't matter. No, of course, that's not how the real world is. But, I invited Steve to the event today. So I invited him to the event over the weekend, the tournament. I invited him to the live stream today. So maybe he's out there watching, and maybe after today's episode, we can make him into a believer that there actually is a lot of value in learning, some better ways to work through these challenges and practicing, especially with common type geometry like line, arc, line, and centered circles and concentric circles. Maybe there is value in learning how to do it just a little bit faster. Incremental improvements maybe do kind of add up and help you make deadlines a little bit quicker than your competition. Maybe, maybe not. We'll see if he watches this week. If you guys are out there and disagree, if you think that there is value in learning how to do some common applications quickly, feel free to support the channel. You can go in and you can like the channel. There's 22 people watching right now. There's only one like. So here's a little content creator hack. I'm going to go over to my monitoring computer and I'm going to click the like button. And that way we'll go from 1 likes to 2 likes. So if you're one of the 22 people watching live right now, be sure to hit that like button. I'm reading the chat here as I'm going through the presentation, so I'll circle back and answer some of these, but I do appreciate the feedback. I know you guys know what's up. It's all good. If you want to support the channel, another way that you can do it is you can share and reshare. So you could take a screen capture of some of these challenges and go out on your social media, and you could say, hey, this is a pretty cool challenge. Maybe you should try it. Maybe link back to some of the videos I've been posting. And of course, if you want to support the channel, you can join the mailing list at TooTallToby.com. It's right on the main page. And that way we can stay in touch if anything ever happens to the wonderful world of YouTube. And if you want to support the channel financially, there's really 3 avenues that work. Super Chat, which is available right now just down under the chat. You can choose Super Chat and you can send me some financial support. You can say, here's some money, so you can buy a cup of coffee or a beer or a case of waters or whatever it is. You can do super thanks if you're watching this in a recording format. And I have now set up PayPal to accept donations. So if you go to TooTallToby.com, right on the main page, there is a support TooTallToby link. And if you want to go that route, there's a lot of options. You can use PayPal, you can use credit card, and you can even set up a monthly donation. So if you just want to say like, hey man, I really like what you're doing, I want to keep this channel going, here's some support. It's kind of like a value for value model. If you feel like you're getting value out of this channel, send me some value back, and that's how we can really take this channel to the next level and just continue to grow. So excited to have that set up now properly, and it's available over at TooTallToby.com. And thank you all who are supporting. There's a lot of different ways you can support. You could like, you can subscribe, you can share, or you can provide financial support. It is all very much welcome and very, very much appreciated. I want to say thank you back to the people who gave me super thanks since the last stream. Sylvain T who gave me a shout out on that CAD vs. CAD tournament, and Garrett K gave me a shout out on these practice models, which I'm going to take a look at in just a moment. I'll share that with you. And Victor says, speed modeling at the highest level is mostly for fun. Things like the Ivan exploit are a good example of just something just for show. That said, speed modeling makes my day-to-day much nicer. Awesome. I agree with what you're saying there, Jed. Very nicely said, Victor. Very well said. That's it. You got it exactly. There's these little things that you learn that just save you so much time throughout the day, and it's just kind of nice to know. And this is the place where you can learn those little things. Now, if you are in that professional environment, working day to day, kind of like what Victor's saying, at that highest professional level, one thing that might help you would be having some good, solid hardware to work off of. And if you're in need of any hardware, you can definitely check out the crew over at SolidWorks. What SolidWorks tries to do is provide you with SolidWorks-related hardware that'll help you avoid running into errors like this. There's nothing more frustrating than getting a brand new computer and ending up with an error like this. And so what the team at SolidWorks will do is they'll not only help you figure out what type of hardware would be appropriate depending on what you do at your job, but they'll also go through and they'll make tweaks to both Windows and to the BIOS of that computer just to make sure that it is optimized for professional level engineering for both CAD and CAM users. And so if you are in the need for a new computer, if your team is looking to upgrade your computers, be sure to check out mysolidbox.com. Let them know that Toby sent you. They will definitely take care of you. They'll help answer all your questions. They'll provide support, before, during, and after the sale for that hardware to make sure that you have everything set up the way you need it. And if you need any additional tweaks or anything, they offer a lot of services to help with that too. So be sure to check that out, mysolidbox.com, if you're in the position to get some new hardware. And speaking of professional CAM users, I want to say thank you to Cam Smith for the super chat there. Have a nice IPA on me. I will do that, Cam. Thank you very much. And Thomas Dunn says, can anyone match me? Come on. Thank you very much, Thomas Dunn. Very much appreciate the support. Keep this channel going. Keep it alive. Keep it thriving. That's what we really want and need. All right, with that, let's get into the Model Monday Live CAD speed modeling challenges. And so when it comes to the CAD speed modeling challenges, we are going to show you a 2D print, and we're going to ask you to turn that into a 3D model. Is anybody out there in the chat here today for the first time? Let us know in the chat if you're here for the first time. And if you are here for the first time, it'll be important for you to know kind of what the rules are, which is we're going to show you a 2D print. We're going to have you turn this into a 3D model and then calculate the mass. And you're going to enter that mass in the YouTube chat. And so I see in the YouTube chat, Kirby says, I'm here for the first time. Jose says, I'm here for the first time. All right, welcome, guys. Welcome, welcome. So this is going to be basically what the flow is. I'm going to show you a 2D print, and you're going to try and turn that into a 3D model and calculate the mass. And Jason O, shout out to Jason O. Thanks a lot for the $5 super chat. I like that sticker as well. So the basic rules here are that you can use any CAD package. As long as you can input density and output mass, it doesn't matter what the CAD package is that you're using. It could be SolidWorks, it could be Onshape, Fusion 360, Inventor. Any CAD package, as long as you can input a custom material density and output mass, you are good to go. And just make sure when you answer in the chat, you use the specified precision. So you're going to calculate the mass and then just type that into the chat. And whoever comes up with the mass first is going to be considered the winner of this challenge. And the units that we work in and the materials we work in are listed here. So if you are here for the first time, maybe just use a screen capture tool like Windows snipping tool and grab this material information so that you will have it available. You won't be confused. And eventually, if you start doing these often, you'll probably want to make a template or add these materials to your materials library so that you know what materials to expect whenever you're going through and doing these challenges. It's always one of these three materials. It's always either an IPS or MMGS for the units. And as far as advanced rules go, well, this is meant to be fun and good-spirited. There's no prizes for the Model Monday Live competition. It doesn't really give you anything other than bragging rights. But, maybe eventually I'll get a team together and I'll have them go through and scrape the data, and we'll have like a long-running record of everybody who ever won. But for now, it's really just meant to be fun and good-spirited. And on that note, the examples that I've got today are going to be, I'm recycling some examples from back in the old days, just because I've been so busy prepping for the tournament. So, don't cheat, right? Today, this is just for fun. There's no need to cheat. So even if you've modeled it before, don't go back and open up your old model or go back and check the old live stream. Just, create a new model again. Just do it again. See if you're any faster than you were before. And along the way, I do occasionally make mistakes, like I forget a dimension or a relationship, or like in one of the examples today, one of the views, I don't have the hidden lines shown, but I didn't actually make a note that says hidden lines are not shown. So it's like, there's going to be little things like that. I'm not a master drawing creator yet. Maybe one day I will be. And the Ivan exploit is permitted and sometimes encouraged. but really a lot of times discouraged because of how I create the geometry. All right, let's get into it here, guys. I'm gonna flip over to full screen. And what's gonna happen here, again, for those of you who are here for the first time, I'm going to show you this print, like Jason O says, like Foreigner says, it feels like the first time. Great song. So what's gonna happen here is I'm going to show you this 2D print, and you're gonna do a screen capture. And once you do that screen capture, you're gonna immediately begin modeling. And the first person to calculate the mass of your 3D model, type it into the chat, and that person will be declared the winner if they get the mass correct. So here we go. In 3, 2, 1, I'm going to show you an older print. This one comes from the old December 14th tourney. 3, 2, 1, go. So here we go. What is the mass of this part in x.xx pounds? So this is one of these models that is in inches, not millimeters, IPS. The material is ABS, and the density of that material is 1020 kilograms per cubic meter. What is the mass of this part in x.xx pounds? So I'm just going to leave that up on the screen for another 10 seconds. Hopefully that's enough time for you to grab a screen capture and start modeling. See what you come up with. I remember this one. I think Allness did this one. I think it was Allness against Clint. I think that's who he was going against. I could probably look it up. But if I remember correctly, that's who it was doing this model. So this was another good old matchup. All right, guys, let's get into it here. We're going to do some live solves from the tournament. We've been running this 3D CAD tournament now for, I guess, about 8 weeks. We had started out with 32 people and 10 people on the waiting list. We had a couple of people drop out, so I'm glad we had that waiting list ready to go. There were 12 different countries that registered. I think it actually might be 13 now that we have members from the waiting list. And 5 different CAD systems registered as well. And what we saw was, the bracket started out with 32 runners out on the outsides of those brackets. But here we can see in the black bracket, 3 of those runners have fallen. 3 have advanced into the round of 16, which is going to begin on October 22nd. And some good matchups in there, some really good matchups in several different CAD systems we saw in there. And same thing can be said for the blue bracket here. We saw several different CAD systems, and we saw people who unfortunately did not advance, and we saw people who did advance in the blue bracket. And we'll see the first round of 16 on October 22nd. But we're not quite there yet. You can see down at the bottom of the blue bracket, there's still room for some people to advance on the October 8th matchup. If we move down here to the red bracket, we can see that, again, we've got 2 matches that have concluded. Those top 2 matches have concluded, so that leaves Neil going up against Ricardo J on October 29th. But down in that lower section of the red bracket, we haven't had anybody advance yet because we haven't had those matches. Those next matches are going to be on September 24th, and we're going to be continuing to get people into the round of 16. And then finally, over here on the mustard bracket, same thing. We've had 2 people who have advanced. Tom Smith and Yaya TK were able to advance for their match on October 29th, but no one has advanced down below yet because we haven't had those matches. So that's what's going on with the tournament. And if you want to get the tournament, if you want to get yourself set up so that you've got the information directly in your calendar, just head over to TooTallToby, click on the link that says calendar. I have all of these dates in the calendar for all the upcoming matches, and that'll let you create a calendar appointment so you don't forget it, you don't miss it, and you can tune into those tournaments live. And so on that note, I thought that it would be appropriate to go through and take a look at some of these previous models that we've seen during the tournament. And the first one I'm going to take a look at here is called Slide. So what I'm going to do here is I'm going to use, in my case, I'm going to just use Windows snipping tool, and I'm going to grab a full screen of this so that I can model this thing. But before I start modeling, I think that we should, just talk a little bit about kind of what the game plan is, because anytime you are presented with a challenge, whether somebody gives you a 2D print or whether somebody gives you a napkin sketch, or even if it's just something that you see in your house and you want to design a 3D model, you always have to ask yourself the same questions. You always have to ask yourself, what is going to be my starting plane? What is going to be my starting profile? And for me, my strategy is always keep your sketches simple. I always want to keep my sketches simple. I don't want sketches that are, too crazy and too difficult to work with. So I always try to keep my sketches simple. And so in the case of this model here, what I would probably do, and this might seem a little bit counterintuitive, I would probably actually start with this sketch here. And again, the idea is keep your sketches simple. So I would probably start with this sketch here on the top plane. That's going to be my starting plane, starting profile. Now, why am I doing that? Why am I choosing that plane? Well, it kind of captures the biggest footprint of the design, and it gives me a nice foundation to work off of when I start creating some of the other features. So some of those other features might be like this fin here that's sticking up off the top, or this region down here that's sticking down off the bottom. Those regions, I just think they're going to be easier to create if I create that top geometry first. And this is something that's kind of subtle that's in this design, this challenge, but this does come up in the real world, and that is that this lower centered section, comes out actually, it looks like it might almost come out further than the fillet, right? You can sort of see that here in this angled, you can sort of, whoop, oh boy. I think I'm all of a sudden over driving. Stand by, guys. I think I have a loose connection. Wow. Sorry about that, guys. Little loose connection there. Things went a little crazy. I think we're back now. Yeah, so this is a little bit subtle, but in this region up here, you can see that the center fin comes out, and it's interfacing with this fillet in kind of a weird way. And so, just knowing what we know about manufacturing, that should tell us that we really want to make sure that we have that fillet created first, and then go back in and, we want to have this angled face created first, and then go back in and fill it so that we fill it around that entire corner. So that's my game plan for this design. If you haven't had a chance yet, you may want to just grab a screen capture of this if you want to follow along with and see how I go through this. But, I spend a lot of time kind of describing what the game plan is going to be so that I don't have to spend that much time doing the actual CAD. When it comes time to doing the actual CAD, I just want it to work. I just want to kind of rip through this thing. So let's take a look here at the doing the actual CAD part of this whole thing, and just kind of move this interface into place here so that we're good to go. Let's take a look and see what we got here. Sorry about that microphone issue, guys. I hope that the audio is all sounding good again here. If it's not, I'm sure you guys will let me know, and I'll keep an eye on the chat as well as I'm going through this thing. So here we go. New model. I'm going to use a template that I've created that is in IPS and ABS. I'm going to go top plane, begin a sketch, orient my view, S key, rectangle. So I'm using the S key on my keyboard to bring up that shortcut menu that I use a lot. And then I'm using my smart dimensions to get these dimensions in place right from the jump. So that just saves me a lot of time going back in. And then the final move I'm doing here is pick one, hold control, pick the other, let go of control, and make that midpoint. Now I'm ready to extrude that, and I'm just going to extrude that up to the height of 0.75, and that gives me that kind of foundational geometry to begin my design. Now I'm going to go front plane, begin a sketch, and I'm going to take this edge here and convert it, because when we do convert entities, we're getting that nice, solid, dynamic relationship that we can rely on later in the design if we need it. So this is going to be 2 minus 0.75. Just in case you can't do that math, you can let the software do the math for you. This is going to be 6 minus 3, or 3. That one I can do in my head, believe it or not. And then I can just kind of bring this thing over like so. And the final dimension here, S key smart dimension, is going to be between these 2 points at 0.5. So now we're ready to extrude that, and we can see over on the left here, the depth of the, whenever you click extrude, the depth of that extrusion begins highlighted. So this is another place you can save a lot of time, because here what we can do is I can do S key, extrude, And once I do S key extrude, I can immediately begin typing in the depth of that extrusion. In this case, it's 1 inch. So I can do 1 inch, enter. Now I can go back to my mouse, right mouse button, mid plane, and then right mouse button again. Now, in that case, I kind of talked through the whole process, but in real time, it might look something like this. S key, extrude, 1, enter, right mouse button, mid plane, right mouse button again, and you're ready to move on to the next feature. So for that next feature, again, I'm going to do a centered feature, front plane, begin to sketch, orient my view, S key, start the line command here. I'm going to go this point, come up, single click, come back and hold my mouse over that endpoint, come around, and then give that thing a radius of 0.5, enter. So now I've got my tangent arc with the radius already dimensioned. That's another great place to save some time. And then we can do S key and we can create an angle dimension here, and that angle dimension is going to be at 30 degrees. And so now the only thing that's left to do is just add in this dimension here from the bottom. And if we want to, we could make that cut extrude in the same sketch, or if we want to, the hole, or we can make that as a separate sketch. In production, I would always make it as a separate sketch. The sketch is still blue, and I'm not sure why, so I'm just going to grab a blue point and move it, and oh, okay, I can see tangency is not present. So how can we quickly add tangency? Well, we can just click on this endpoint and then come up here and choose Make Tangent. So we don't have to like go into any menus or anything or pick one, hold control, pick the other. You can just pick that point that's at the intersection of those two entities and make that tangent. Now you're ready to move on. S key extrude. That thing has a width of 0.75. Enter. Move my mouse, right mouse button, mid plane, right mouse button to finish that as well. Pick this face, begin to sketch, orient my view. S key, circle, pick here. Type in the dimension to 0.5. S key, extrude cut, right mouse button, through all, right mouse button again to add that cut extrude. And so now the final couple of features are just these holes that are up top. So S key, begin to sketch, S key, circle, and we're going to make this here at a diameter of 0.5. And then for the second one, we could copy it. We could make these two equal. There's lots of different ways that we could get these guys to do what we want them to do. Here, I'm going to pick the origin, hold control, pick these 2 points and make that horizontal. And now the only thing left to do is add the dimensions. So this guy has a dimension from the end here of 0.75, and this guy has a dimension from the end of 2. S key, extrude cut, right mouse button, through all, right mouse button again to finish that, and then S key, fillet, and this is going to be a constant radius fillet with a radius here of 0.5, enter, and we'll pick this edge and this edge. And so now at that point, oh, and by the way, that fillet, after you pick that second edge, usually you can just right mouse button to finish. So I can pick S key, fillet, the radius is highlighted, so the first time I was on full round, so it was a little bit funky. But usually if you start out and you're on constant here, then the radius over here is highlighted. So that means that as soon as you get into the command S key fillet, you can immediately 0.5 type the radius. And then you can pick the first edge and then move your mouse. And then this is like left mouse button, right mouse button. So you like left, right, done. So it's like another really good move to learn when you're trying to, learn these common commands that we use all the time in SolidWorks. Like how can we quickly get through creating a fillet? Well, if you just learn that workflow, S key, fillet, immediately type in the radius, pick the first edge, pick the second edge, pick the third edge, pick the last edge, and then immediately right click. That really can help you speed through that process of adding those fillets. So we should be pretty close to the correct mass. Let's see what we got here. Evaluate mass properties. And we got a mass property of, we need this in 3 places. So we'll go here, options, 3 places. And mass properties, 0.491. So then I would take that and I would copy and paste it into the chat. And let's see if we got it correct. Jump back to our PowerPoint here. And the answer was yes. Yeah, we did it. We got it. 0.491. And of course, during the tournament, that was Rafi Rahman who did that one and got it correct. And that's why I got his logo up there. So let's take a look here. I'll skip over this next one for now. And if you guys like that, if you guys like seeing how a SolidWorks expert might think through some of these challenges, again, if you believe in the power of speed modeling, if you weren't here at the beginning of the presentation, just a quick reminder, you can support the channel with a like, Looks like we've got 15 likes so far. We've got 26 people watching. So you can, if you're watching any of the videos, you can always add a comment. You can subscribe. If you want to provide some financial support, you can use Super Chat down in the chat right now underneath the chat. You can use Super Thanks, or you can use PayPal. And you can always share and reshare on your social media. If you think any of these challenges are cool or any of the videos are cool, please share and reshare and let more people know about the good word of TooTallToby. And I saw a lot of answers coming in here, so hopefully you guys have had enough time to answer this one. Let's see, how much time do we have? Maybe I'll do one more. You know what? I'm going to do one more speed modeling answer here from the tournament, just because you know, I think we still have time for people. There may still be people working on that that first one that we had. This rolling back through here in the PowerPoint. This guy here. So there's probably still people working on this one. I only saw a few answers come in so far, so I'll just give people maybe like 5 more minutes, and I'll just blast through this other challenge from the tournament. So this guy here, I'm going to start out by doing a screen capture. I'm using Windows snipping tool, but you can use whatever snipping tool you want. If you have a recommendation for a good snipping tool, put it in the chat, and other people can learn, you know, learn what works. And this part is called L stop. This was in the tournament a few weeks ago. And again, you know, whenever you have these challenges, it's really just about deciding on what is a good starting strategy. And I think in the case of this model here, for me, again, this is just like what really jumps out at me. I look at the whole print. I look at everything that's on here. For me, I think that this shape really jumps out at me. So starting here at this point, coming across, coming up like this at the 15-degree angle, over, down, over to here, and then straight down. So my strategy would be to do that shape first and extrude it out to in this case, the 85 width. And then after I have that shape, I'll go back in and I'll create this cut extrude just as a single arc with a radius of 80. And that's just going to make it a little bit easier for me to go through and visualize that design. And I might even, you know, create this tombstone shape first, and that way I can reference that center point of the tombstone shape for my radius 80. You know, sometimes thinking through these types of designs, whether you're speed modeling or designing for, you know, professional environment, it's good to kind of come up with a plan and understand how your different features are going to be related to one another. So that's how I would start out on a model like this. If you want to play along with, feel free to grab a screen capture of this print and see how long it takes you to model. If you're watching the recording, you could just pause the video, model it up yourself, and then you can watch the recording back and see how I do it. But this model is in MMGS, and it is in 1060 aluminum alloy. So I'm going to flip back over here to my SOLIDWORKS environment and start a new part and try to create this model. So I'll go new here, and I'll go 1060 aluminum alloy in MMGS, front plane, begin to sketch, orient my view, and I'm going to start out at this point here and create a line that comes over at a distance of 135, and then a line that comes up here at a distance of 12. You can see how using these auto dimensions can really save you a lot of time. And then I'm going to come over and down like so, and then I'm going to add in my overall height here, which is 65, my distance from here to this flat spot, which is 25, and then finally the angle at that location, which we could do with the magic dimension arrow if I can somehow catch that edge of that line. I don't know if I'm going to be able to. Oh, I did. Look at that. So we can use the magic dimension arrow. I think I made a video about that last year at one point. S key extrude, and that's going to go out to 85, and again that's going to be mid plane, and then right mouse button. Now this face here, begin a sketch, orient my view, S key, and maybe I will go to the top here. Click a line that comes over, a line that comes over, a line that comes out, single click, come back, touch the end point, come out and around, and then give that a radius of 26, enter. So that line arc line and then typing in the radius can be a huge time saver if you can learn, you know, and kind of predict how it's going to behave. So a couple of relationships here to get that thing locked down, and then a dimension that goes from, how is this thing located? Oh, it's just located from the edge of the model. Wow. So I did it in the wrong order here because I actually need this edge of the model here coming off the 135 to give me the center point of this arc here, and then that gives me the location of the tombstone. So I actually did it out of order. I did it in the wrong order there. So, okay, no problem. You know, that's the power of SOLIDWORKS. We can always roll back in the tree. Begin this, pick this face, begin a sketch, orient the view, and I'm going to create my 3-point arc here. And again, right in this command, I can just type in the radius, even though I'm doing a 3-point arc. And also, even though I missed this point here. So coincident, and then I'll take this guy and make this vertical. And then I'll take this guy and make this tangent. And that should give me the correct location for that arc. Now, S key extrude cut. Now this one, we're gonna do what's called through all both directions. And when we do through all both directions, what we end up with is essentially a surface cut. And we just have this one arrow here that we can click on to change what gets cut away. So if I wanted to cut away everything on the model, I would do this flip side to cut, and it would cut everything over here. But that's not what I want. I just want to cut away the outside there. Okay, so you only have to make that one arc. That entire sketch just looked like this. I didn't have to create, you know, like the extra junk that might stick out on the end there. Just make that one sketch through all both directions, like a surface cut. So now I can roll forward here, and then we have our tombstone, and now we will be able to locate this point or the arc concentric to this arc here. S key extrude, and that's going to come up to a height of 8, and then that's going to have a C-bore going through it. So always good to learn how to read the C-bore information. I know this is a little bit of an advantage for the SolidWorks crew versus people that are using other CAD systems, but when you're looking at a call out like that and you're working in SolidWorks, you can basically just type in the information in order. So 15, 30, 10. Well, that's the same order that the hole wizard gives you the information in when you do a custom hole wizard hole. So if we go hole wizard here, and then we say that this is going to be ANSI-metric, but we're going to use a custom sizing, we can type in 15, then over here with my left hand, tab, and then I know we're losing this in the UI there. Okay, so 15, tab, and then this one is going to be 30, tab, and then 10 for the depth of the C-bore, tab, and now we're ready to go out and add that to this face here. So we wake up the center point, add that to that face, and there's your C-bore. So again, I know that's a little bit of an advantage for SolidWorks users over some of our other users, but maybe in their CAD packages, the hole wizard works similarly, or if not, you just have to learn, it's a pretty standard C-bore call out, so you just have to learn how to read it and then what the order would be in your CAD package. So this guy has a radius down here of 15. I missed the auto dimension, and has a vertical point here. And we're going to go from the top down to here at 20. S key, extrude cut, right mouse button through all, right mouse button. So that same workflow that we've talked about a lot. I made a lot of videos too, like about right click end conditions. I think that's what those videos are called. So definitely a good video to check out, that right click end condition video, if you want to learn how to save some time on some of this. So this one's 5, 10, 5. So 5 for the through hole, 10 for the counter bore, and then 5 for the depth of the counter bore. And then we go to positions, and we could probably do this a lot of different ways, but just because I like sketch mirror, I would probably do it by just getting in here and drawing a vertical line, and then window select and mirroring across that window select. So now that gives us 2 points to define to, with a distance of 55 between them, and then a distance down from the top at 10 millimeters, which is important because that back wall is drafted. And if you don't drop them in the right spot, if you try to use the Ivan exploit there, you're probably going to end up with the wrong mass. So just about done here. 2 more features, I guess. So S key, 3-point slotted hole. So we go 1, 2, 3, like so. This is going to be concentric again to one of these. This is going to be vertical again. Let's see here. I guess because those points are on the... seen this happen before where because it's a slot, it kind of behaves like a traditional block in other CAD packages, and it can be a little bit feisty to get the relationship that you want. I've definitely seen that happen. Okay, so that has a radius of 8. This has a radius of 60. And finally, we have an angle on this thing. Is that how we close this out? Okay, yeah, an angle. So this is an open angle of 50, so this will be 25. S key extrude cut, right mouse button through all. And then the last one here is the fillet that's on those corners, which is a radius 20 on both of those corners. So radius 20, radius 20. Give it a final spin. Say, yep, it looks good. I think I got everything. Let's take a look at our mass properties. So evaluate mass properties on this one. And I'm coming up with 499.2 for the mass. So I'll add that into the chat. And let's see how we did. So we go back to our PowerPoint. And Neil was the one who got this one correct, and he also got 499.2. Yes! So I'm in good company there with Neil getting that one correct. So that's just an example of kind of like looking over the shoulder of a 3D expert, SolidWorks expert, showing you kind of how I use some of these moves to get through these challenges. And it's not just it's not just these speed modeling challenges, but these are moves that I use in my actual work. One of the ways that I make income is through hourly work, contracting type work, and these are moves that I use all the time to try to give my customers the best possible hourly rate and get them the most work possible in 1 hour. So there's a lot of reasons to learn how to do things quickly, but of course it doesn't matter how fast you are if you get the information wrong. So you not only have to be able to create models quickly, but they also have to be accurate so that they fit together with other parts, and you can ultimately build assemblies of components that are correct. Alrighty, so again, if you like that kind of content, be sure to like, comment, subscribe, support. Lots of different ways to support here. And let's see who got this answer correct. Let me see if I can bring up the chat here. I think it is this one. Yep. Okay. And I'm just going to make this a little bit more narrow. So let's see here. Who was the first one to come in? I think it was Cam, right? Yep, I saw that when it came in. So Cam comes in 1.23 pounds. Nicely done, Cam. Airwick coming in 1.20. Cam revising to 1.20. Victor 1.20. Jed Hightower 1.20. Texas Mike. What's up, Texas Mike? I saw you in the comments on one of those videos. Welcome to the party. 1.2 pounds. Jose coming in 1.20 pounds. Barry coming in here 1.13. Thomas coming in 1.20. We got Trail Fazi coming in 1.21. I've seen a lot of comments from you as well in the different practice videos. Great to see you in here. Jason O 1.21. Victor giving me some tips and tricks here. Roll the sketch back and keep working on something else. Yes, improvise, adapt, overcome. I like it. Let's see here. Revising to 1.20 says, darn, missed it by that much. What do you end up missing? I'm curious, Tralfazi. What did you end up missing that you were able to find and revise to get down to 1.20? Let's see here. And Tiago says, what is the difficulty level of this part? I'd say these are all, high-level beginner parts. They're only a handful of features. There's nothing that's too tricky about the features. We don't get into like a lot of draft or like multi-thickness shell or swoopy lofty stuff. So I'd say these are like high-level beginners. If you went through the SolidWorks Essentials training class, or if you took a beginner's training class with me, shout out to beginners training classes with TooTallToby. If you want any info on that, hit me up on the contact page. If you took a beginner's training class with me, you got to the end of the class, you'd be able to make all these parts. Maybe not as quickly as some of the other people in the chat, but you'd definitely be able to make them. What locates the larger C-bore in the left top right view? Which part are you referring to there, Cam? LOL, I was just typing. Never mind. Okay. Okay, wrong chat. Okay, line shifted over off of the point. Yeah, maybe accidentally picked up a relationship to a line or missed a relationship to a line. All right, guys, let's see what the correct answer is on this one. The correct answer is 1.20 pounds. So congratulations to Cam Smith. Oh, no, I'm sorry. Congratulations to Airwick, who came in with the correct answer first. And congratulations to Cam and Victor, who were right behind him, and to Jed and Texas Mike, and everyone else who got this correct. 1.20 is the correct answer. All right, let's do another one, guys, before we run out of time here today. Here we go. This next challenge is going to go live. So I'm going to give you guys one more challenge today, speed modeling challenge for all the fun people in the chat. And you have about 17 minutes before you get to the top of the hour. So if you have to go at 2 o'clock, then that will be your time limit. And I'll probably run just a couple minutes overtime today. Here we go. 3, 2, 1. Actually, this one I think has a bumper too. So, yeah. So this is another one from the tourney in December 2020. This one is called Interlock. Go. This is one of my favorite models, so I'm glad to be pulling this one out again. And your challenge is to take this model, which is in plain carbon steel, 7,800 kilograms per cubic meter, and turn this model into turn this drawing into a 3D CAD model, and tell me what is the mass of this part. So what is the mass of this part in XXX grams? That's your challenge today here. So take a screen capture of this part so that you can keep working on it while we go through the PowerPoint and talk for just a few more minutes about the world of TooTallToby. Of course, if you're just watching, that's fine, and feel free to give this thing a like. Tralfazi says, good game. You guys are on another level. Yeah. These guys are, they're pretty serious, right? They're seeking out the live stream for CAD speed modeling on a Monday afternoon. This is the serious crew in here, for sure. All right, let's see what's going on. Just some quick chatting, some quick updates about what's going on in my world. I made a video to announce this, but I am going to Texas this weekend, and I'm going to be there for 2 weeks. I'm going to be visiting 5 users groups, SolidWorks live in-person users groups. So if you are in the Texas area, be sure to check this out. This is going to be a lot of fun getting together with people in person, starting in Houston, then going to Kilgore, and then going to Dallas. That's the 20th, 21st, 22nd. Then going down to Corpus Christi the following Monday, and then ending up in Austin on the 28th. So just kind of doing a big loop here. Kind of looks like a bass clef symbol. If there's any musicians out there, kind of makes like a great big bass clef symbol. So it seems appropriate. And then we're going to end up in Austin with Steve Calvert's user group. Very excited to see people in person doing a live tips and tricks. It's a brand new presentation as well. This is the user group leaders have done a great job of putting together advertisements for this on Meetup. You can check out the description of this live stream that you're watching right now to get the links to all of these meetups if you want to register and attend one of these. It's going to be a brand new Toby's Tips and Tricks 2022. We're going to talk about sketching, multi-body importing, sheet metal, weldments, assemblies, and more. Lots of tips and tricks, about a 90-minute presentation. So it's going to be a good one, definitely one you want to check out in person. It's always more fun in person. And just a couple other things that are going on. If your company's looking for any training, I am available to do contract training. I've taught over 200 professional SolidWorks training classes. I've fielded over 10,000 SolidWorks tech support cases. So whatever your company needs, if we do a kind of like a pre-meeting and talk about what you're looking for, I'm sure that I can either use one of my existing classes that I've just recently written, brand new classes that I've written, or we could even write a custom class for your needs. So let me know if you're interested. You can just hit me up on the webpage. Lots of different topics that I can teach. I got them all listed here. Basically, like I said before, anything you need in SolidWorks, we can make it happen. And you can just hit me up on the contact page at TooTallToby.com, my website. Send me a message, say, hey, my team's interested in getting some training. We'll make it happen. And of course, the value for value model continues. We talked about this a little earlier. You can give me value. If you see value in this channel, you can send me some value back. We had some people send some super chat earlier. Very, very much appreciate that super chat. But anything that you see out here, if you ever see that you're getting value from this channel, one of the things I started doing recently was adding back in those practice models. So these used to be called Model Monday Replay. Now I've renamed them to practice models. But basically the same idea. You get a little timer on the screen, and you can practice creating a 3D model from a drawing that you know has all the dimensions you need to create that 3D model. You can time yourself. You can let me know down in the comments how fast you were. If you run into any challenges, let me know that. And what's coming next is going to be the tutorials to explain how to do each of these models. So, check this out. It's a good little series that I started here, and these are just going to keep going. I've got, as I'm sure you can imagine, I've got a lot of models in my archive, and so I'm excited to be able to share them with everybody. I think this is a great format to do it because it lets you have some practice on models that you know are fully defined, that are kind of like upper beginner level models. I want to also just give a quick shout out to all the people who have given me super chat over the past couple of weeks. It's been a while since we did a live stream. So Jason O hooked it up on August 15th, as did Chris K and Thomas D. So thank you so much for that. And Cam Smith. Thank you guys so much for that. During the August 27th tourney, Victor K got out there and showed some love, showed some support with super chat. So thank you so much, Victor K. As did Brad M and Andreas A. And Jason O, once again, Jason O. So thank you so much. And Andreas A, again, coming through for us on the September 3rd tournament. This super chat is a great way to help keep the channel going strong and helping to grow the channel. Maybe I'll even take on a team of people someday. I don't know. We're not quite there yet. maybe someday though. I got dreams for sure. And on September 10th, we got some super chat support from Olive Dogs, from Andreas A once again, from Ian G, and from Marcus Gray. So thank you so much to all the people that are helping out, hooking up the super chat. It's very much appreciated. It goes a long way towards keeping the channel going, and it really is meant to be a value for value model. So if you're getting value out of this, feel free to send some value back my way. And I almost forgot Kachu as well on the September 10th tourney. Sorry about that, Kachu. Alrighty, let's do one more Model Monday tourney solve here before we run out of time. So this is going to be another example of you kind of looking over the shoulder of a SOLIDWORKS expert. This one here is called Tool Holder. This is a challenge that we had for some of our participants during the tournament. And you can see here it's in MMGS, plain carbon steel, and it has 7,800 kilograms per cubic meter. So, you know, step one, as always, when you're doing these challenges, is to grab a practice model here, or sorry, grab a screen capture here, reading Victor's chat and scrambling my brain. And now we're going to come up with a game plan. So on a model like this, the model is circular. You can imagine taking a cross section of the model here, taking half the cross section, and then just ripping that around a center line. That's what's called a revolve in 3D CAD. With a model like this, oh, I'm sorry, it's going to look like that. With a model like this, that's almost certainly what you're going to do. This is usually not really that's subjective. Most of the time people are going to do it this way. You certainly could do it other ways, but eventually you're going to have to do some type of a revolve here, like a cut revolve. So you may as well just do the whole thing as a revolve just right off the bat to get started. So I remember, I think Neil Custard was working on this one, and I thought it was really clever the way that he did the counter bores with a sketch cut extrude offset. So maybe I'll do something similar just to show you how he did that. But that's going to be the game plan. So the game plan is going to be create the main revolve shape, then come in here and blast this cut extrude through the middle, and then finish up with these little holes here and with these little counter bores here. So let's take a look here at the SOLIDWORKS software and see how an expert might go through and perform a challenge like this. So it looks like what we're going to do... Oh, I got my date wrong here, huh? That's not good. Hold on a second, guys. Can't have this wrong. Boom, fixed. So it looks like what we're going to do here is we're going to start out with a new part. This part is in plain carbon steel MMGS. So plain carbon steel MMGS part template. Pick a face, begin a sketch, orient the view, or pick a plane. Come across here with a dimension of 60, because it's 120 over 2. Come up here with a dimension of an unknown quantity. And then it looks like, it's kind of hard to tell, but it looks like the cut revolve there is, it's really hard to tell. It looks almost like it's not directly on that that edge. How did I define this thing? It's weird. Sorry guys, I'm getting confused by my own print. 15 up. It's like these are sticking out a little bit here. Did I miss a dimension on this thing? Oh, here we go. 8 to tangent. There's the dimension that I was missing. Okay. A little bit weird there. Sometimes you get these like napkin sketches from people and you'll have the same type of internal dialogue as you're trying to figure out what the heck these people are showing. So I'm just trying to help you guys get prepared for that when you go out into the real world of engineering. All right, so this is going to be a dimension that goes from this line, hold shift, pick this arc. That's how you get the dimension to tangency quickly. And then that's going to be 8 to tangency. And then this whole thing here has a radius of 10. And finally, we've got this geometry, which is collinear. So we'll just make that collinear. And now we're ready to move on with the rest of this design. So we come over here, up, all the way up, over, and close this thing off. Now, if you want these double dimensions, you can create your center line a little bit earlier. Like that, if I wanted that 60 to be a 120, I could have created that center line a little bit earlier, much like what I'm doing with this 220 here. And then for our final dimensions, we just need the height dimension here of 95, and we need the height to this lower section, which is 45, and then the height to the center of that circle, which is 15. There we go. And now we can go to Features Revolve. We can take that kind of cross section that we created and fully defined, and we can turn it into a revolved shape. And now we can go to Right Plane, Begin a Sketch, Orient the View. This is going to be another one of these extrude cuts through all in both directions. So, you know, in a spot like this, actually, I probably would let me Control Z that. So we go Right Plane, Begin a Sketch, and then when we create this rectangle, let's create it with some dimensions on it, if we can find the dimensions. So this has a depth of 40, oh wow, okay. I'm not gonna be able to get that depth. So I'm just gonna press Tab, and then I'm going to type in 150 for the direction there, and there you see, I only end up with the one dimension. I don't have to have both dimensions. By pressing Tab and then just pressing Enter, you can kind of bypass that one dimension, because that dimension's coming from down here, so that would have been hard to like math out. And this will be through all in both directions again. There we go. And now the final thing that we need to do is just add in those holes and those counterbores. So we could do the kind of the same thing here. We could do Right Plane, Begin a Sketch, or Front Plane, Begin a Sketch, Orient the View, and then create a circle here with a diameter of 10 through. This is how Neil did it as well. And I thought, like I said, I thought it was really clever the way he did the counterbores coming off of this thing. So we could either mirror it at the sketch level or mirror it afterwards, but because of how the dimensions are on these holes, maybe it makes sense to, you could go either way. You know, sometimes if I have multiple features, I will actually opt to do the mirror afterwards as the feature, just to, just make it a little bit simpler. But so right mouse button through all both, right mouse button. And then what Neil did here was he picked this face, begin a sketch, begin the circle command, wake up this center point. And so we go here to the center point and then come out to a diameter of 24. And then he woke up this center point as well, and then came out here to a diameter of 24. So now he's got those things ready to cut extrude, but when you go to cut extrude, you're going to be cutting from this surface here. Well, what Neil did, I thought this was really clever, was he looked at this print, and he noticed on the print here that there's this 15 dimension over here, which is coming from this inside wall to the beginning of that C-bore. And so to accomplish that, what he did was he just went here in SolidWorks and said, don't offset from extrude from the sketch plane, offset that extrusion, and then put in that dimension, the 15 millimeters, and then just reverse the direction of it. And there we go. Now he's got that counter bore at that 15 millimeters off. So I thought that was a really clever solution. That was a lot different from how I would have done it. I probably would have done it with like a revolve from the top, and it would have taken me a lot longer to come up with that solution. So it's, again, one of these benefits of being able to see other people model. Sometimes you're like, oh, yeah, that's a kind of a cool way of getting through that challenge. I like that. And then maybe you can find a spot to use that later on. All right, so we do the final spin, look over this model, say, yep, looks like we got everything that we need. And with that, let's go into our evaluate mass properties. And we come up with a mass of 10323 for our mass there, and type that into the chat, and we see if we end up beating our competitor and then we end up getting it correct. And so let's take a look at what the answer is for this one. Oh yeah, 10323. We did it. We got the answer correct. So I hope you guys find that helpful, being able to kind of watch over the shoulder of SolidWorks Expert, looking at some of these challenges that maybe you've seen in the chat before, and hopefully that helps you to kind of think through some of these challenges in your time as well. And so with that, let's take a look at the answer from the chat here. Once again, don't forget, if you like this channel, be sure to at least hit the like button. If nothing else, hit that like button. We got 25 watching. We got 23 likes. That's what I like to see. That is a good, solid ratio of viewers to likes. Hopefully we made Steve into a believer here. If you weren't here at the beginning of the presentation of the live stream, this is just a comment that I got on social media that I wanted to share that said that speed modeling is no more than a dog and pony show, and basically says that, like, it doesn't matter if you're fast. What matters is if you're doing it right. And I guess if you ever have a detractor come at you and say, speed modeling doesn't matter at all, you should worry about being fast, or worry about being accurate. Don't worry about being fast. What I would say to them is, it's not either or, right? It's not either you're fast or you're accurate, right? It's both. It's both and more. It's not either or, it is both and more. You can have both. I think that's what true mastery of a professional trade is. You not only know how to do it right, but over your years of honing your skill, you've learned a lot of cool ways to do it right and to do it with the least amount of resistance. It's not about doing it fast, it's about doing it efficiently. And that's what I think engineering is all about, is finding efficient ways to solve problems. So there's your philosophy for your Monday afternoon from your buddy TooTallToby. All right, let's see if we got this answer right. Bring up this chat again. Here we go. 1.20. Okay, so here we are. So Victor came in here, 2.27. I saw that one come in pretty darn quick. Airwick right behind him, 227. Texas Mike coming in, 227. Nicely done, Texas Mike. And Rex Sowards is here. What's up, Rex? How you doing? Welcome to the party. Let us know what CAD system you're using. BJH is here, 227. Jed Hightower coming in, 227. 227 here from Trailfazy. And let's see what else we got. Thomas Dunn coming in, 227. Trailfazy says, trailing by 8 minutes. Doing it fast means you know how to do it. Yeah, exactly. Oh, sweet. Rex is here using OnShape. Awesome. We've had a couple of OnShape users in the tournament, and I think we have at least one more still on the roster, and who knows what will happen if people drop out. So welcome. Eric says, go OnShape. 227 is the correct answer. So congratulations to Victor for coming in with that answer correctly. And first, I'm just curious, who out there who is watching did this model using a circular pattern? Who modeled half of it and then ripped it around using a circular pattern? I'm just curious if anybody did that. Let me know in the chat if you were able to do it with like a circular pattern, maybe like a circular body pattern, or maybe you did a circular pattern with even just these features here on this wall. Let's see here. Another question about the Ivan exploit from Kyle Hoffman. Yeah, what is the Ivan exploit? So Kyle's great question. So the Ivan exploit is a cheat that was famously used in one of the first tournaments that we did by our good friend Ivan the Reasonable. And basically what it is if there is a hole here on the outside of the model and it's meticulously defined as far as the location of that hole. So if it's at like a dimension here of like 81.23, and if it's at a dimension over here of like something else, it's like kind of annoyingly defined, like 44.5321 or something. You don't actually have to worry about defining the location of that hole, because the mass that will be removed from this model when you go from this face to this face will be the same regardless of where that hole is. So it's a little bit cheap, it's like if you want to show that you're truly alpha, if you want to show that you're like truly a pro, you don't succumb to such tactics. You just win outright because you're that good. But some people, will look for those. And so what I try to do with a lot of the models that I create, a lot of the challenges that I create, is I try to, I guess you could say, like, counteract that. There's like a counter strategy to that. So for example, on a model like this, you can see that there's a lot of draft in this model to make it a little bit more difficult to leverage an Ivan exploit. Or like this hole that's down here, the 10 millimeters through hole, it's like, it's centered on the tombstone. It's so easy to do that. If you wanted to, you could just drop that anywhere, but it doesn't really make sense. And it makes you look, I'll be honest, it makes you look a little bit weak when you do that in the competition tournament. So, Ivan exploit is okay. It's kind of discouraged, I think. There's nothing I can do to, outlaw it. But what I can do is I can create models that do kind of counteract it and have tight tolerances. So, if you were just to like drop this hole anywhere or drop this tombstone anywhere, you're not going to get the correct mass because of how this wall here is tapering. So, there are some things that I try to do in the prints to help avoid it. And by the way, I'm not talking trash about Ivan at all. He is great and one of my favorite people. It's just I knew that it was an exploit, and I just was waiting for somebody to tap into it, and I saw Ivan do it, and so he ended up getting I guess you could say he ended up getting that tactic named in his honor. I'm not sure if it's a term of endearment having that named in his honor or not, but I love Ivan no matter what, and he's actually going to be on here doing some co-commentary with me in a couple of weeks as well. And so hopefully he doesn't cancel now that I've talked all this trash on him. All right, guys, I'm going to quit while I'm ahead here. I want to say congratulations to our winners today. If you guys enjoyed this type of thing, be sure to check out those practice models that I've been posting on YouTube. Those are a great way to continue practicing and honing your skills and learning some of these repeat moves over and over again. Let's see here what else we got. Thank you to the greatest chat ever. Looking through here at the chat. Let's see here. Airwick said, did it with circular pattern. Victor did it with circular pattern. Airwick body pattern. Nice, nice, nice. Tiago coming in here with 272 for the mass. Nicely done. I think that was maybe a typo, or maybe you're a little bit high there. It should be 227. Let's see here. Yep. Since attorneys are streamed, you can have the chat watching for underdefined sketches exploits. Yeah, I mean, sometimes sketches are underdefined. That's the thing. Like, it's got to be... there just has to be, you know, when you're running a competition like this, there just has to be a definitive way for people to answer. And so the only thing I could really do to counter strategy the Ivan exploit would be to do like a center of mass. But it gets really funky when you're trying to like get that into the chat, especially if you're working with different CAD systems. Like it's just going to be sloppy trying to figure that out. I mean, and again, especially if you're working with different CAD systems, it seems prohibitive. So I just decided to kind of split the difference and say, look, it's okay. You know, your sketches don't have to be fully defined. Like, that's the thing, is that there's going to be spots where, like a sketch like this, a lot of times, even in the production world, I might take a sketch like this and not necessarily have it fully defined on these edges here, you know, and instead just have this horizontal here. Because of whatever reason, like, you know, there just might be a reason. Like, I'm worried that I'm going to lose this edge here because of adding a fillet to this edge could affect the edge ID downstream. So I might leave it just kind of like arbitrarily wide here and not necessarily lock it down. Now, that's an underdefined sketch. Should that disqualify the person? You know, I don't think so. There's plenty of times where I'll end up leaving a sketch underdefined, and I know later on I'm going to use it for something else. And as long as the geometry can be machined correctly or can be 3D printed correctly, I think that should probably be good enough. So, yeah, I mean, I'm just kind of sharing with you guys some of my internal thoughts. I've definitely thought through some of these things before, and, you know, it's, yeah, oh, that's a great point too, Victor. I actually did not think of that. That is an excellent point. If we did center of mass, well, what if two people chose the origin at two different locations? Right now, it's not going to work. Like, everybody's going to have to pick the origin at the same spot. That's not going to work out either. So I think mass is a really good kind of middle ground. And I think it's kind of cool. Like, yeah, there is an Ivan exploit that's capable, and I think it's okay. You know, I think it gives the TooTallToby tournament a lot of character, and I like character, and I like Ivan, and he's a great character as well. And, you know, I just think it's, I like it, whatever. It's my tournament and I like it, so I'm going to keep it. No, honestly, I think it's just, it's a really good balance. It's a really good system that we've got here. It makes me very thankful every day that I'm working with such an amazing crew. You guys give me such good feedback, such good ideas. You help me get smarter as we're interacting like this. So thank you guys so much. Victor says, I got a blast. Yep, I got a blast as well, guys. So thank you guys so much. Remember to support the channel. Remember to share this with other people. Sign up on the mailing list on TooTallToby.com. And I will see you guys later. Keep selling that snake oil, buddy. Yeah, thanks a lot, Jed. That's a great way to end the live stream. All right, you guys are the best. I'll catch up with you guys later. I'm going to be going, like I said, I'm going to Texas this week, so tournament is off this weekend, but it's back on next weekend, and we'll definitely do some live streams and some videos and stuff from the road. I'll let you guys know how I'm doing and where I am. Updates from the road. Be sure to look out for that, and I will see you everybody next time. You guys are the best. Bye.